Hello all, good morning. Today we'll see another important reasoning out question. Why anomalies are more common in children born to older mothers? So why it happens? So to understand that we should know about the oogenesis first. So the oogenesis starts in the intrauterine life. Initially oogonia or the primary germ cell, it gets migrated at 6th week of intrauterine life from the yolk sac to the genital ridge, and it undergoes lot of mitotic divisions to finally form the primary oocyte. So during divisions, about 7 million primary oocyte will be formed during the fetal development, but at the time of birth, the fetus will be having only, or the newborn will be having only 1 million primary oocyte. So this primary oocyte will be present at the time of birth. Remember, after birth there is no formation of primary oocyte in females. Okay, remember that. So after birth, then what happens? Only first and second meiotic divisions will happen after birth, especially during the growth of the child. The first meiotic division will start. However, the first meiotic division will not get completed during childhood stage, and it gets arrested at the prophase stage of meiosis, first meiotic division. So when then that first meiotic division gets completed? Only at the time of ovulation. Only at the time of ovulation, that is when the child matures, when the menarche happens, when ovulation happens, only at that time the first meiotic division will be completed. So the ovulated thing should be of secondary oocyte. So at the time of ovulation, the first meiotic division will be complete and secondary oocyte will be ovulated. So every time when ovulation happens at every month in the female reproductive phase, it is the secondary oocyte that gets ovulated. With a first polar body, this happens because unequal division of the cellular component, especially in oocyte. So this first polar body will degenerate. So this secondary oocyte has to undergo again second meiotic division, but it has ovulated. So when does that second meiotic division will be completed? It gets completed only at the time of fertilization. If no fertilization happens, the secondary oocyte will undergo second meiotic division, but it gets arrested at the metaphase stage of the second meiosis. So it gets arrested over there and it will come out during menstrual cycle if no fertilization happens. If fertilization happens, then the second meiotic division will be complete. And finally, ovum and a second polar body will be formed, and second polar body will get degenerated, and this ovum would have undergone fertilization by the time the second meiotic division is complete. So what you have to understand is that the primary oocyte which is present at birth will only undergo meiotic division further, but there is no mitotic phase to form a fresh primary oocyte. So what happens? The same oocyte which is present at birth will undergo maturation every month in the female reproductive cycle and it gets ovulated. So as the age of the female increases, the age of the primary oocyte also increases because it remains the same as such since birth. There is no new formation of primary oocyte, remember. So the age of the oocyte, primary oocyte, will be similar to that of the age of the women. So what happens as the age increases? As the age increases, every time when the female ovulates, it will be nothing but the same primary oocyte that undergoes first and second meiotic division. So what happens? As the age increases, this meiotic divisions might not happen correctly, which can result in chromosomal disorder, okay, or the mother might be having some comorbid conditions like diabetes, hypertension as the age increases, that can again affect the outcome of the pregnancy. Also, the ovarian synthesis of hormones might not be correct or complete. That can result in miscarriages because of deficiency of progesterone. It can also result in miscarriages. So even in people who undergo ovulation induction, it is better to happen at earlier ages than at older ages, because the ovum which is available already only will undergo ovulation during induction process. Total reproductive life of the women, maximum around 400 ovum would have undergone ovulation. So what happens to the remaining ovum then, or the remaining primary oocyte then? So remember, the remaining primary oocyte will undergo degeneration or atresia in the ovary itself, and only around 400 primary oocyte will completely get ovulated. If you take, that is an approximate value, that will get ovulated during the whole reproductive life of the women. So this number of atresia, the total number of oocytes that undergo atresia will increase. The number of attrition, the attrition rate will increase as the age advances. Hope you understood. Thank you.